Algebra 2 Honors, 9.2, Adding and Subtracting Rational Expressions. So how do we add and subtract rational expressions? This video is going to move fairly quickly, so you may want to pause it, make sure you know what you're talking about. Well, we need a common denominator. When we have a common denominator, it's just like adding fractions. 2/5 plus 1/5 is 3/5. But if you don't have a common denominator, you have to make one. In this case, the easiest way is to just go 5 over 5, 3 over 3. What are we multiplying by? We're multiplying by the number 1. We're not multiplying by some random thing. We're not just throwing a number on top and not a number on the bottom. We're multiplying by 1, which we are allowed to do. When we multiply by 1, we change it into an equivalent form. 10 over 15 is the same as 2/3. And the reason we did that is it gives us a common denominator. We're able to add them then. So 22 over 15 is the correct answer. Rational expressions are just like that with many, many twists. Here we add them, we get 12 over 3x. The problem is we always have to check to see if we can reduce. In our last lesson, we spent a lot of time saying, oh yeah, don't forget, x can't equal 0. We will not be doing that any further. We're just going to focus on simplifying rational expressions. So what should we multiply here? I'm just going to roll over my equals and put that in. We want to get to the minimum common denominator. We could just go 18 over x, 18xy over 18xy. But I don't recommend that because we have to reduce later and it causes all sorts of problems for people. What I do recommend is saying, well, there's a y squared here and a y. So we need to multiply by y over y. There's an x here and no x here. So we need to multiply by x over x. Looking at the numbers, this is a 3 times 5 and this is a 3 times 6. They both have a 3, so I don't have to worry about that. But this one needs a 6 and this one needs a 5. We multiply them together, and on top we get 42x squared over 90xy squared, 5y squared over 90xy squared. Now we've got common denominators. We can add them together. Again, not worrying about excluded values. Please, please, please do not do this. You are adding these two. You cannot cancel one side and not the other. A very common mistake, even by experienced people. So what about subtracting? Well, the first thing I do is distribute the negative. So I end up with 3x minus x minus 5. Very common mistake to forget that the negative applies to the 5 also. We have a common denominator already, so it's fairly easy. 2x minus 5 over x minus 1. This one, it's hard to see what the common denominator is. I am going to distribute the negative, and I'm going to factor so that I get w plus 12 over 4w minus 4 plus negative w plus 4 over 2w minus 4. So we look at that and we say, well, they both have w minus 4s, they both have 1, 2, but we need another 2 over here. Again, don't forget to distribute up top over here. So we get w plus 12 minus 2w minus 8 over 4w minus 4. W minus 2w is negative w. 12 minus 8 is 4 over 4 w minus 4. And a lot of people look at that and think they're done. Well, there's a trick. I'm going to show you the trick again in a few minutes. we can factor out a negative on top. If we factor out a negative on top, we end up with 4w minus 4. The final answer will be negative 1/4. A lot of people confused by that. Just did a ton of math, really don't know what it means. What it means is no matter what number you put in for all these w's, you will always get 1/4. You can put in 7, you can put in pi, you can put in negative 6. I would recommend trying 0 right now, and you will find out that when you simplify that, you get negative 1/4. See if you can do the trick on your own right here. Because I'm going to do it, I would pause the recording. Now, previously we distribute up top, and we're not going to do that this time. We're going to distribute on the bottom. So we get 4x plus 1 plus 2x minus 5. By distributing on the bottom, we end up making x minus 1. We had to look at it and have enough intelligence to say, oh, look at that. That will give me a common denominator. If you factored out the negative, it would have worked that way too. This one's a little bit easier. We can use this to simplify complex fractions. We already know this is x minus y over a plus b times a squared minus b squared over x squared minus y squared. We've done this kind of problem already. X minus y, a plus b times a minus b, x plus y times x minus y. Cancel, 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 cancel. A minus b over x plus y. Again, we're not going to worry about excluded values. Now life gets a little trickier. I'm going to leave this as a fraction for a minute. I'm going to leave myself some space to put my common denominators in. As we did before, we're just messing with the top of the fraction, but as we did before, common denominator. Y over y, x over x, x over x. So now I get y minus x over xy, x plus 1 over x. Now we're back to where we've been before. Y minus x over xy times x over x plus 1. Only thing that cancels here are the x's. And we're left with y minus x over x plus 1. Again, not worrying about excluded values. So here's a practice problem for you. I would pause the recording, see how you do. Now I'm going to do it. x1, y1, x2, y2. Slope is y2 minus y1 over x2 minus x1. You can see it's going to set up like a complex fraction. 3 over p minus 1/2. 1/3 minus 2 over p times 2 over 2 times p over p times p over p times 3 over 3. Equals 6 minus p over 2p divided by times 3p over p minus 6. Factor out a negative. 6 minus p. You can cancel. P's also cancel. And your slope is left at negative 3/2. It's a neat problem. It's a challenging problem, but it's a neat problem. If I lost you somewhere in these two steps, look up above, make sure it ties all together for you. That's it. Good luck.